Okay, so the next thing that we have to discuss here is the general and middle terms of the expansion of a binomial. So you have the general and middle terms. And so there are a few points that need to be noted here. First of all, in the binomial expansion for a plus b raised to the power n, we observe that the first term is, of course, n combination 0 a raised to the power n. Right? This is the first. This term over here is the first term. And and the second term is always n combination 1a raised to the power n minus 1 times b. This is the second term. And the third term is basically n combination 2 a raised to the power n minus 2 b raised to the power 2. This is always the third term. This is always the third term. And basically so on all the way up to basically n combination n b raised to the power n. And looking at the pattern of the successive terms, we can say that the r plus 1th term is basically, so this is basically, this is if you take r as, so basically what they're saying is that the r plus 1th term is always n combination r a raised to the power n minus r b raised to the power, which is of course true in the case of any of these terms, meaning that here you have n combination some r, for example, being 0 here, and then you have basically n a raised to the power n minus 0 b raised to the power 0, which is equal to 1 here. So we have not written that here. Or when this number is 1, then you have n combination 1 a raised to the power n minus 1 b raised to the power 1, and so on and so forth. Which means that well, of course, this is the first term. This is the first term, and if I call this basically r plus 1th term, if I call this r plus 1th term, you can see that over here, basically r plus 1 is equal to the first term. So here your r becomes 0. When it comes to the second term, if you take the second term as r plus 1th term, then your r becomes 1, and then your r becomes 2 and 3, and so on and so forth. So then you can, in that sense, you can say that r plus 1th term is always basically equal to n combination r a raised to the power n minus r b raised to the power r. And they had to say r plus 1th term because basically the index of r here starts with a 0, not a 1. Otherwise, they would have called it, for example, the rth term. But it's just not possible based on the situation. So, so then you can say that then basically the r plus 1th term, this term over here, is also called the general term of the expansion, is also called the general term of the expansion a plus b raised to the power n, right? And it is denoted by t of capital T of r plus 1. And thus, in the case of a plus b raised to the power n, capital T of r plus 1 is equal to n combination r is equal to n combination r, a raised to the power n minus r, b raised to the power r, right? So that we already know about these expansions. Now, this was basically the first point to be noted here. The second point to be noted is that regarding the middle term in the expansion a plus b raised to the power n. So let me write this. I don't really know. So number 2. So regarding the middle term, in the expansion a plus b raised to the power n, we have number 1, if n is even, then the number of terms in the expansion will be n plus 1. Then the number of terms in the expansion will be n plus 1. Now, since n is even, so n plus 1 is odd. Of course, since n is even, then n plus 1 is odd. And when you're dealing with an odd number of terms, of course, that would be like, for example, a 9. So a 9 would be 8, 4, and 4. So, for example, suppose that you have 9 terms over here. So 3, 6, and 9. So you can take basically 4 terms on this side and 4 terms on this side, and this term would be exactly in the middle of these 2 terms. This is when the number of terms is odd. When the number of terms is even, this is when, for example, the number of terms is 9. Suppose that the number of terms is even, for example, it is equal to 8, then you have, for example, something like 8 terms, 2, 4, 6, and 8. And then in that case, basically, you can take basically 4 terms over here, 4 terms over here, and there will be no terms in the middle. So you have to basically take 2 terms in the middle, meaning that you have to take these 3 terms here, these 3 terms here, and these 2 terms. These 2 terms will be the middle terms of the expansion of that binomial. So then what that means is that then basically if n is even, then the number of terms in the expansion will be n plus 1, and n plus 1 will be of course odd. Therefore the middle term is going to be equal to, and therefore the middle term is going to be equal to So if you pay attention to the way that I found the term, you have to basically you have to essentially subtract 1 when the number of terms is odd. When the number of terms is odd, the number of terms is odd, then suppose that, for example, you have 9 terms over here, 2, 4, 6, 8, and 9. And since the number of terms is odd, then what you can do is that basically subtract 1 from the number of terms, and then the way that I found that the middle term here was that I took basically 4 terms from here, 4 terms from here, so that means that I actually left one of the terms out. And then I divided the remaining number of terms, I divided that by 2, and then as a result of that I got this 4, which I took from the left hand side, 4 from the right hand side, and as a result this 1 term remained here. That means that you can subtract 1 term from the whole number of terms, and then divide the number, whatever remains, divide that by 2, and then the term exactly next to that or after that will be the middle term. And so you can actually do the same thing over here, meaning that if n is even, if the number of terms is n, and if n is even, so then you have to essentially basically now this n over here refers to the index of a plus b. So the index of a plus b is equal to n, of course, always is equal to n. I mean, in standard cases it's equal to n. So, and you know that in the expansion there is always 1 term more than the index of the binomial, meaning that then the number of terms over here becomes n plus 1, right? And we know that n plus 1 is odd, right? So then what I will do is that I will subtract 1 from this term, which would give me basically subtract 1 from n plus 1, which would give me an n, and then divide this by 2, divide n by 2 in order to basically go half the way just before the middle term. So then that gives me n divided by 2, and then I have to add 1 to that, which gives me n divided by 2 plus 1, n divided by 2 plus 1, and therefore n divided by 2 plus 1th term will be the middle term. Right? So that's the formula that you can use for the situations where your number of terms is odd, right? Now, in the situations where the number of terms is even, then of course we argued that you would get basically 2 terms, essentially 2 terms in the middle, and those 2 terms would be the middle terms of the expansion. Now that was, of course, I thought that we would take the mean of those two terms, but that's not actually possible here. That was related to statistics. But essentially, now what you can do, now using the formula that we just found, for example, you can say that in the expansion x plus 2y, raised to the power 8, so you can see that over here n is equal to 8, which is an even number, which implies that the number of terms in the expansion will be 8 plus 1, which is equal to 9, which is an odd number. Now, since the number is an odd number, then the middle term, and that implies that the middle term is found by n divided by 2 plus 1, which means that then the middle term would be equal to 8 divided by 2 plus 1, which is equal to 4 plus 1 is equal to the fifth term. So when you say the fifth term, now if you want to find a general formula for this fifth term, what you can do is that previously we said that basically we said that r plus 1th term is given by the general term of the expansion. We said that the general term of the expansion which is equal to r plus 1th term, that is given by basically n combination r, a raised to the power n minus r, b raised to the power r, right? That is the general term of this expansion, which means that when you're dealing with the fifth term of the expansion, at the fifth term basically your r plus 1 at the fifth term, r plus 1 is equal to, so basically at the first term your r is equal to your r at the first term your r plus 1 is equal to 1. At the second term your r plus 1 is equal to 2. At the third term your r plus 1 is equal to 3. That means that at the fifth term your r plus 1 is equal to 5. Right? And therefore over here your r plus 1 is equal to 5, and r is equal to 5 minus 1, which is equal to 4. Right? So r is equal to 4. Now you know your r, you know your a, your a is equal to basically x, your b is equal to 2y, your r is equal to, what was that, is equal to 4, and your n is equal to 8. Therefore the fifth term of this expansion Therefore, the fifth term of this expansion is going to be of this expansion is going to be basically so here we said that at the fifth term r is equal to 4. R is equal to 4. And I have written everything over here. So generally you have n combination r, a raised to the power n minus r, b raised to the power r. And that means that then you can write basically 8 combination 4 a, which is basically in this case x raised to the power 4, and 2y raised to the power r, which is in this case equal to 4, and that would be, for example, your fifth term, or the middle term basically. Right, so that is basically how you use, for example, what we have learned so far. And basically these concepts, I mean, it takes essentially a little bit of time until you get comfortable with them. So the first time you might need to think a little bit too hard in order to solve a problem related to these concepts. But over time you will be okay. Now the second point here to be noted related to the middle term is if n is odd. Number 2, if n is odd, then n plus 1 is even. Then the number of, let me write it properly. So then you can say that if, then you can say that if in basically a plus b raised to the power n, n is basically n is odd, then n plus 1 which is the number of terms, in the expansion of a plus b raised to the power n, will be, of course, will be even, right? Because n is odd, so n plus 1 becomes even. So there will be 2 middle terms in the expansion. There will be 2 middle terms in the expansion. Now, the 2 middle terms the way that you can find them is that, for example, suppose that n plus 1 is basically, suppose that n plus 1 is even. That means that you have 8 terms, for example, over here. Suppose that you have 8 terms over here. If you have 8 terms over here, so of course, if I divide the number of these terms by 2, I would get basically 8 divided by 2, which is 4. And if I pick 4 terms from here and 4 terms from here, there will be no terms over here. So the middle term is just simply not there. So what I need to do is that I have to just simply find a logical way to get to the two middle terms in the middle. And suppose that you have 8 terms over here, right? 2, 4, 6, and 8. So what I can do is that if I subtract 1 from these terms, I would get 7. 7 divided by 2 is going to give me so suppose that basically I subtract. Now let me find some way to find this. Okay, so now in the expansion of basically a plus b raised to the power n, if n is odd, then n plus 1 is going to be even. Meaning that, for example, if you have 2x minus 7 minus y raised to the power 7, here your n is odd. So therefore you will get 8 terms over here. And if you had 8 terms, so then the middle terms would be 2, 4, 6, and 8 terms over here. So then the middle terms would be basically the 4th term and would be the 5th term, right? So then you can so the 4th term would be basically n plus 1 divided by 2, n plus 1 divided by 2th term, and that the 5th term would be n plus 1 divided by 2, the next term after that plus 1, plus 1th term. And you can just keep doing the same thing, meaning that, for example, if you have 2x minus y raised to the power 9, for example, you would get 10 terms over here, which is again an even number of terms. So 10 terms, 2, 4, 6, 8, and 10. And so you have basically 4 terms over here, 4 terms over here, 8 and 2. So you have 4 terms over here, 4 terms over here, and so you get these 2 terms as the middle terms. Meaning that the 5th term and the 6th term over here are the middle terms. Again, n plus 1 divided by 2 would be basically 10 divided by 2 is equal to 5, and n plus 1 divided by 2 plus 1 would be the 6th term, and therefore you can use these 2 formulas for the middle terms of the case when n is odd, basically, right? So then you can argue that basically when it will be even, so there will be 2 middle terms in the expansion. And you can write that as namely n plus 1 divided by 2th term, n plus 1 divided by 2th term, and basically n plus 1 divided by 2 plus 1th term, so in the expansion, for example, 2x minus y divided 2x minus y raised to the power 7, the middle terms are basically n plus 1 divided by 2th term, which would be basically 7 plus 1 divided by 2th term, which is equal to 4th term. And n plus 1 divided by 2 plus 1th term, which is equal to 7 plus 1 divided by 2 plus 1th term, which is the same thing as 8 divided by 2, 4 plus 1 is equal to 5th term. And that makes sense because when you have 7, when n is equal to 7, you get 8 terms over here. You get 8 terms over here, so you would have basically 3 terms from this side, 3 terms from this side, and this would be the 4th term, and this would be the 5th term. And that's basically what we have gotten here. Now, one more thing that we will note here is that in the expansion of x plus 1 by x raised to the power 2n, where x is not equal to 0, the middle term is basically 2 plus 1 plus 1, 2n plus 1 plus 1 divided by 2th term, that is n plus 1th term, as 2n is even, and which is given by basically 2n combination n. Now this term, if you paid attention to one of the exercises that we did, this term is independent of x. X is not there because essentially somewhere in the middle of the expansion, since you're multiplying x by 1 by x, and here you have different powers of x and different powers of 1 by x multiplying together as you go through the terms, somewhere basically the powers of x and the powers of 1 divided by x are equal, and therefore x and x in the numerator and denominator will cancel out. This whole thing becomes 1, and the only thing that remains is the coefficient of the term, which in this case is basically 2n combination n, right? Is 2n combination n. And this term is called the term independent of x, or the constant term of this expansion. Now let me write this down properly, and then we will do some examples. Okay, so then basically note number 3 was that, okay, so about number 3 we said that basically in the expansion of basically 1 plus 1 by x raised to the power 2n, where x is not equal to 0, the middle term is basically n plus 1th term, as 2n is even, right? As 2n is even. Now, to understand this, basically you need to first find and that is basically x plus 1 by x raised to the power 2n. So the middle term of this expansion would be basically, when we said that when n is even, we said that when n is even, the middle term, so basically we said that in the expansion of a plus b raised to the power n, when n is even, the middle term is given by basically n divided by 2 plus 1th term. When n is even, then the number of terms in the expansion will be n plus 1. n plus 1 is odd, therefore the middle term is n divided by 2 plus 1th term. right? Now, n plus 2 plus 1th term. Now here, basically, in the case of this expansion, n is basically equal to, or the index is equal to 2n. And this number over here is actually the index of the expansion in this case, right? So now, then we can say that therefore the middle term of x plus 1x raised to the power 2n is given by basically, you have to, wherever you see n in this formula, you substitute it with 2n. So you have 2n divided by 2 plus 1. That would be this term, which is the same thing as basically n plus 1th term. n plus 1th term. So the nth plus 1th term of this expansion would be the middle term of the expansion, right? Now, how do you calculate the n plus 1th term of this expansion? So this expansion is basically n plus 1th basically n plus 1th term. So we know that the nth term of so basically, you know that the first term of the expansion, so basically if you have the expansion, for example, a plus b raised to the power n, so then the first term of the expansion would be, for example, n combination 0, a raised to the power n, plus n combination 2, a raised to the power n minus 2, b raised to the power 2, plus all the way up to n combination n, a raised to the power 0, b raised to the power n. So this is the first term. This is the second term. This is the second term. And this is the nth term. The general term of this expansion, right? The general term of this expansion. Which means that basically in this expansion, x plus 1 by x raised to the power 2n, the general term is given by, so in this, the general term is given by basically n combination n is given by basically n combination n, a raised to the power is given by basically the nth term is given by n combination n, a raised to the power n minus, or n combination r, n raised to the power n minus r, b raised to the power r. This is the general term of any expansion, really. So now when the index is 2n, you can write basically basically the general term of this expansion would be basically 2n combination r, a raised to the power 2n minus r, b raised to the power r. This is the general term of this expansion. Now, if I want to calculate basically n plus 1th term of this expansion, here the only thing that I need to do is that I need to make some changes to this, and that would be basically, you see over here, when I'm dealing with the first term, here your r is equal to 0. second term, your r is equal to, this is actually supposed to be equal to 1, right? N minus 1 and b raised to the power 1. So basically the number of term is always one more than r. So that means that so then you can say that the number of the term is always equal to basically r plus 1. Is always equal to r plus 1. That means that if I want to basically find the n plus 1th term of this expansion, the number of term plus 1 would be r again plus 1, so that would be r plus 2, right? Would be r plus 2. So what that means is that basically, so again, let me go back over here. We said that when the number of terms is term is 1, r is equal to 0. When the number of term is 1, r is equal to 0. When the number of term is 2, r is equal to 1. So r is always basically one less than the number of term, or the number of term is always given by r plus 1, which is correct here. Now over here, the number of term that I'm looking for is basically the number of term that I'm looking for is n plus 1, right? So the number of term is n plus 1, right? This is the number of term, and therefore r is always basically the number of is always basically one more than the number of term. That means that over here, or actually one less than the number of term, right? So I'm sorry, I'm confusing you here, but I'm trying to find a way to get over this problem. So over here you can see that the number of term is 1, r is 0. The number of term is 2, r is 1. So when the number of term is, let me write a table over here. I think that would be the best way to deal with this problem. So if I take this as the number of term, and if I take this as r, when the number of term is 1, r is equal to 0. When the number of term is 2, the r is equal to 1. When the number of term is equal to 3, then that would be equal to 2. That means that when the number of term is equal to n plus 1, so you can see that always you can, from the number of term, you can subtract 1 and you will get your r. So that would be n plus 1 minus 1, which is equal to n, right? So that means that n plus 1th term of this expansion, that means that n plus 1th term of the expansion would have r is equal to n, right? So then you can simply put this over here in this formula, and then you will get the n plus 1th term of the expansion of x plus 1 x divided raised to the power 2n, which would be therefore the n plus 1th term would be equal to basically 2n combination r, which is basically n, and a raised to the power 2n minus r. So 2n minus r would be 2n minus n, which is equal to n, a raised to the power n, and b raised to the power r, which is equal to b raised to the power n. And again, your a over here is x, your b is 1 by x. That means that would be equal to 2n combination n, x raised to the power n, times 1 divided by x raised to the power n. And then you would have x raised to the power n here. This is 1 divided by x raised to the power n. These two will be cancelled out. You will have 2n combination n. Is 2n combination n, right? So, which is of course a constant. And this term is called the term independent of x, or the constant term, right? Now, let's do a couple of examples here first, and then we will have a couple of exercises, I'm sorry. Okay. Okay, so question number, or example number 5, we have find a if the 17th and 18th terms of the expansion 2 plus a raised to the power 50 are equal. So the example is example number 5, which basically you need to find a if the 17th and 18th terms of the expansion of 2 plus a raised to the power 50 are equal. Now, one thing that we need to do first before answering this question is basically we need to know exactly how to find the nth term, of the expansion of a plus b raised to the power n. How to find the nth term of the expansion of a plus b raised to the power n. So basically we said that T of r plus 1 of the expansion of a plus 1 would be equal to r plus 1th term, and that is equal to basically n combination r, a raised to the power n minus r, b raised to the power r, right? So what this means is that basically for example, if you have a plus b raised to the power n, that is equal to n combination 0, a raised to the power n minus 0 b raised to the power 0 plus n combination 1 a raised to the power n minus 1 b raised to the power 1 plus n combination 2 a raised to the power n minus 2 b raised to the power 2 plus all the way up to n combination n a raised to the power n minus n b raised to the power n, right? So that means that when we say t of r plus 1, what we mean by that is basically the term in which basically r is equal to so for example, if I say that, if over here you can see that r is equal to, over here you can see that r is equal to 0, right? Over here, and this is the first term. Over here r is equal to 1, and this is the second term, right? Which means that basically I can say that t of r plus 1. Let's write this formula and see which one of these terms we will get. So now take r is equal to 0. Take r is equal to 0, and we will get basically, and we will get t of r plus 1, t of 0 plus 1, which is equal to t of 1, which is equal to t of 1 is equal to basically n combination r is equal to 0. So that is n combination 0, a raised to the power n minus 0, b raised to the power 0, right? If r is equal to 1, then t of 1 plus 1 is equal to t of 2 is equal to n combination 1, a raised to the power n minus 1, b raised to the power 1. So as you can see, this is actually the first term here. This is actually the first term here, and this is actually the second term here, right? So that means that basically when I say if t of r plus 1, if that becomes t of 1, then you will find basically, you will find the first term, and if t of r plus 1 becomes t of 2, you will actually find the second term, right? And that depends on the value of r basically. So now we can use this information in order to solve this problem, right? Now to solve this problem, what we can do is that we can find basically the 17th term of the expansion of 2 plus a raised to the power 50. To find the 17th term of the expansion basically of 2 plus a raised to the power 50. And that would be basically the 17th term would simply be t of 17, right? Which would be the same thing as t of 16 plus 1, because that is t of r plus 1. And so that means that here your r is equal to 16, right? Your r is equal to 16. Now the general form of these of the expansion, the general form of the expansion of a plus b whole raised to the power n, which we call basically r plus 1th term, denoted by T of R plus 1. Of course, we said that it's equal to n combination R, a raised to the power n minus R, b raised to the power R, right? So that's the general term of the expansion a plus b raised to the power n. That is basically, which is also the R plus 1th term, which is denoted by T of R plus 1, and that is n combination R, a raised to the power n minus R, b raised to the power R. So what that means is that we can basically do the following. Okay, so now, for example, to find the 17th term here, all that you need to do is that in the general form of the expansion of this, you need to put, for example, R is equal to 16. So if R were equal to 16 here, you would get basically n, which is 50 combination 16, and then the first term raised to the power 50 minus 16 is equal to 34, and times a raised to the power, for example, 34 plus 16 is equal to 50, and a raised to the power 16, right? So that would be the 17th there. Moreover, in order to calculate the 18th term of the expansion, you would have T of 18 is equal to T of basically R plus 1, which is equal to 17 plus 1, which means that your R here is 17. So you would write 50 combination 17, and basically 2 raised to the power 50 minus 17 is equal to 40, and 33, and a raised to the power 17. And now now we are saying that these two terms are equal, so that means that 50 combination 16 times 2 raised to the power 34, a raised to the power 16, is the same thing as 50 combination 17, 2 raised to the power 33, a raised to the power 17, which means that you can, if you divide one of these by the other one, you will get a 1. So if I divide both sides by, for example, this one, I would get 50 combination 16, 2 raised to the power 34, a raised to the power 16, and divide that by 50 combination 17, 2 raised to the power 33, a raised to the power 17 is equal to 1. Now, 50 combination 16, 50 combination 17, if you want to simplify that, you would get that is n combination, let's say n combination or you can write it as 50 combination, for example, 16 divided by 50 combination 17 is the same thing as basically or you can write it this way. Basically, you can write that as basically 50 factorial divided by 50 minus 16 factorial times 16 factorial, and then the denominator becomes 50 factorial divided by 50 minus 17 factorial times 17 factorial, and then if you, that is basically 50 minus 16 is equal to 40 and 34. That's 34 factorial here. That's 50 factorial, 34 factorial, 16 factorial. And then over here you have 50 factorial over, that's 40, 33 factorial times 17 factorial. And that's the same thing as 50 factorial divided by 34 factorial times 16 factorial times basically the reciprocal of this, which is 33 factorial, 17 factorial, 50 factorial. These two you can cancel out. Now 33 factorial by 34 factorial is the same thing as, you can think of that as, for example, n minus 1 factorial over n factorial, right? If you take 34 as n, then this becomes n minus 1, and that would be basically equal to basically 1 times 2 times 3 all the way up to n, and that would be 1 times 2 times 3 all the way up to n minus 1. And this, you have an n minus 1 over here as well. So you can simplify all of these here. This becomes 1 divided by n. This becomes 1 divided by n, meaning that you can write this as 33 factorial by 34 factorial times basically 17 factorial by 16 factorial. And so here you would get 1 divided by n, since we got n as 34, that would be 1 divided by 34. So this whole thing would be 1 divided by 34. And n, if I take 17 as n, and so that would be basically n factorial by n minus 1 factorial, that would be basically an n in the numerator. That would be the reciprocal of this, which gives me a 17 here. That would be a 17, and therefore 17, basically that's 1 divided by 34. That's 1 divided by 34 times 17, which is equal to 17 34ths, which is equal to basically 2 times 17 is equal to 2 times 17 is equal to 34, so you have 1 and 2, that's 1/2. So this part is 1/2, so that means that I can basically I can simplify this as 1/2. And then the rest is probably simpler than that. So then you can say that 2 raised to the power 34, 2 raised to the power 33. So over here you would get 2 raised to the power 1 basically. So this would be a 2. And a raised to the power 16, a raised to the power 17. Here you would get an a over here. So that means that, and then you have a 2 and 2 over here. And so 1 over a is equal to 1, which means that a is equal to 1. Right?